so I want you to think back to when we did parallel lines in chapter 3. It would have been like the beginning of quarter 2, somewhere in there. When we talked about parallel lines, we did all of the like, if parallel lines cut by transversal, then all these things are true. Like corresponding angles are congruent, and parallel lines would give you alternate interior angles congruent, all that kind of stuff. And then in the next lesson, we turned everything around. So remember, those are the ones where you had to say, if two lines are cut by transversal and alternate interior angles are congruent, then the lines are parallel. Okay, or if the two lines cut by transversal form consecutive exterior angles that are supplementary, then the lines are parallel. All of these 1 through 6 are ways to prove parallelograms. So instead of knowing it's a parallelogram and using properties, we're going the other way around. So these are ways that are sufficient to prove the quad is a parallelogram. Okay, the first one being the definition. Okay, we talked about the definition yesterday. Remember, definitions are biconditional. They're if and only if. So by definition, what would you need to know to make the parallelogram, a quadriparallelogram? It's called a parallelogram. Parallelogram. What would you have to know to make the quadriparallelogram?
They have two sets of parallel lines.
Yes, thanks, Meg. So if you have a quadrilateral that has two pairs of parallel sides, then it's a parallelogram by definition. I tend to write two pairs of opposite parallel sides. You don't actually have to say opposite for this part, for this particular way to prove, because the ones that are parallel have to be opposite. They can't be consecutive or they would intersect. You can also say two pairs of opposite sides that are parallel. So it doesn't really matter about the order, just like when we did the converses before. Okay, so that one is the definition. Now, all of these are ways to prove that a quadrilateral is a parallelogram. I'm going to go through and highlight all of those right now. All of these are if such and such and such and such is known, then the quadrilateral is a parallelogram. If a quad has these properties, then the quad is a parallelogram. If a quadrilateral has this information known, then the quad is a parallelogram. Here's sufficient information to prove the quad is a parallelogram. If you know that the quad has this property, then the quadrilateral is a parallelogram. Okay. The idea being all of these are going to start with some kind of property and end with then the quadrilateral is a parallelogram. So here's some different, these are all going to be theorems. Okay, these are all theorems. So the first one's the definition. All of these are theorems. The second one, what is that showing? Just look at the picture and the given there. If, what is it showing you? I want to talk to some people who have not answered questions. I'm ready.
If a quadrilateral has two pairs of opposite parallel lines.
It's not parallel. What is it showing?
Congruent.
Yeah, congruent. If a quadrilateral has two pairs of opposite sides that are congruent, then the quad is a parallelogram. Okay. And again, you can say opposite congruent sides, but you have to say two pairs and you have to say opposite. So, two pairs. Now let's do opposite first. Here are things that are not parallelograms. I'm going to give you kind of like things to watch out for, because sometimes students leave out the words like two pairs, leave out the words like opposite. And so I want to make sure you understand why you have to have those words there. Otherwise it won't be true. So what is that thing? Ooh, yuck. Let me try it again. It doesn't like me drawing. So it doesn't like me drawing. It won't let me. I don't know why sometimes I can draw fine and other times it doesn't like me doing that. Okay, fine. I've done this 2 periods in a row and now it's acting up. Okay, these are the same and those are the same. What is that thing?
It's a kite.
That's a kite. So you have to be careful that you say two pairs of opposite sides that are congruent, because a kite has two pairs of congruent sides. It's just that they won't be the opposite sides. Okay, so if you leave out the word opposite, that theorem will not be true anymore. It won't be a theorem. Okay, and then you also have to say two pairs. Here's an example of something that is not a parallelogram. What is that?
A trapezoid.
Trapezoid. Does anybody know what you call it when it has, these are called legs, when the legs are congruent? It's a specific kind of trapezoid. Okay. What do you call a triangle that has at least two congruent sides?
Isosceles.
Isosceles. So that means that you've got a quad that has two congruent sides, but not two pairs of congruent sides, and even two opposite congruent sides, right? So you need to be careful, because if you leave out some of those adjectives there, you're going to make a statement that's not actually true. By the way, a kite is different than a rhombus. Okay, a kite has two pairs of congruent sides that are consecutive, but cannot all four be the same. In a rhombus, all four sides have to be congruent. So when you think about, sometimes students try to think of those like diamonds. A rhombus and a kite are different shapes. And as we're going through the parallelograms, I'm going to be kind of talking to you about different properties of these other quads that we'll study more in depth later. I just want to make sure that you kind of know some of these things to use as counterexamples. And that also it makes it a little easier when we start talking about kites, like as its own thing, you kind of already know some things about kites. Okay, so you have to say a quad having two pairs of opposite sides that are congruent, then it'll be a parallelogram. All right, the next one. If, what does it mean if you have this one, this angle D being X and angle A being 180 minus X? How are they related?
They're supplementary.
They're supplementary, right? It'd be the same thing this way. These would also be supplementary. Okay, so that's saying that there is one angle that is supplementary to both of its consecutive angles. Okay, so you've got this one angle supplementary to both consecutive angles. If a quad has an angle that is supplementary to both of its consecutive angles, then the quad is a parallelogram. And they've got to be consecutive. Okay, so why is that true? Well, we know in a parallelogram, all the pairs of consecutive angles are supplementary because they're all consecutive interiors with parallel lines. But remember going the other way around, if you know that A and D are supplementary, that will make this line and this line parallel with what transversal? What transversal would you be using?
AD.
AD. So oops, that would make the green lines parallel, right? If we do the same thing with the purple lines, so if those are supplementary, that would be using these two lines with this transversal that would then make those sides parallel. And then you have a parallelogram because it has two pairs of parallel sides that are across from each other. So you don't actually have to check all of the consecutive angles being supplementary. It is sufficient to know that one angle is supplementary to both consecutive angles. If a quad has an angle that is supplementary to both consecutive angles, then it's a parallelogram. Let's see. You need to have both because I'm trying to think of some counterexamples here. Point out. Actually, let me just do a generic trapezoid. In a trapezoid, whatever these angles are, let's say this is like 50 degrees. This is just a generic trapezoid, okay? And that one would have to be 1 through supplementary. So in a generic trapezoid, because those lines are parallel, that'd be universal. You'd have to have those angles being supplementary. In a trapezoid, you'd also have another angle over here. I'm going to use 30, I'm going to use 40. Another pair of supplementary angles over here. Okay, so you have to be careful you say an angle supplementary to both consecutive angles, because if it's supplementary to just one of them, all that tells you is that there's one pair of parallel sides. Okay, you have to have both there. If you don't say both, it's not going to be true. Let's see. I think that's the main thing you want to look out for. Okay, the next way to show a quad is a parallelogram. What is that showing? Someone who has not talked to me.
Opposite congruent
Opposite
angles.
Congruent.
Andrew, go ahead.
It's showing two opposite congruent angles.
Not just two opposite congruent angles.
Two pairs.
Pairs, yeah. And again, it's super important you get that word pairs in there. If a quad has two pairs of opposite angles that are congruent, or opposite congruent angles, then it's a parallelogram. Okay, so if we only have one pair of opposite angles that are congruent, it doesn't necessarily have to be a trapezoid, because it could be a kite. There we go. Okay, in a kite, this is a property. Again, I'm going to kind of go over some properties with you as we're coming up with counterexamples here. In a kite, it has one pair of opposite angles that are congruent. And so if you don't say the word pairs here, it's not going to be a true statement. If you just say if a quad has opposite angles congruent, then you didn't really specify that there's two pairs. A kite has a pair. A kite has opposite angles congruent, but just one pair. Let's see. The other thing. Trying to think of another. That's the only thing I'm thinking of right now. Okay. Next method. Marin, what is being shown? If the quad has, what's being shown?
Diagonals that bisect each other.
So if the quad has diagonals that bisect each other, Melissa, what's another way of saying that? They bisect.
Intersect.
I'm sorry, or
Intersect.
how? Where do they intersect?
At the midpoint.
They intersect at their midpoints. They share a midpoint. It's okay to say they intersect at their midpoints. If the diagonals bisect each other or share a midpoint, then the quad's a parallelogram. You have to be careful that you say that they're bisecting each other and that their midpoints are this, and or that their midpoints are the same. Because again, here's a counterexample. If you don't say the diagonals bisect each other in a kite, it really does not want to draw me a kite. I don't know why that happens sometimes. You guys have any helpful tips, let me know. I don't know why sometimes it'll make a kite for me. Sometimes it will try to turn into a parallelogram. Okay, in a kite, if you draw on the diagonals don't bisect each other. These will be the same, but the other one will not be bisected. So you have to make sure you say bisect each other. And also you want to make sure that if you just say they bisect, it might seem like they bisect angles. Okay, so just be careful again with the wording. So the first method was the definition. The next ones are, I just realized I meant to do those in green. The next four are all converses of theorems from the last lesson. And the number 6 is different. It's one that is helpful, but doesn't actually come from a converse of the theorems in 6.2. So what you're given here is that the same pair of sides is what? Anya, tell me what that.
Parallel and congruent.
Oh, you're good. Okay, thank you. The same pair of sides is both parallel and congruent. Okay, parallel and congruent. If a quad has one pair of opposite sides that are both parallel and congruent, then the quad is a parallelogram. Now again, be careful. If you don't say one pair, if you just say if a quad has sides, opposite sides that are parallel and congruent, I might think you mean that. Okay, it's got to be one pair, the same pair of sides. Why is that not a parallelogram? That's a what?
Trapezoid,
What kind of trapezoid?
isosceles.
An isosceles trapezoid. Okay, isosceles trapezoids only have one pair of parallel sides, so they're not parallelograms. But you got to make sure that you're thinking that the same pair of sides are both parallel and congruent. Okay, the same pair of sides are both parallel and congruent. All right, here's kind of a summary. What I want to make sure you remember is that the definition is the one that talks about parallel, right? Parallelograms are called that because they have opposite sides parallel. The definition of parallelogram is the one that uses parallel. So this one is proof that the opposite sides are parallel. And then you've got 3 of them that go along, 4 of them that go along with being converses of theorems from the last lesson. Then you've got the one that's different, that's kind of like its own thing that combines parallel and congruent. Okay, you're given in this problem that the quadrilateral has certain properties. There's 4 different problems there, okay? Given the condition that angle A is congruent to angle C and angle B is congruent to angle D, is that sufficient to say that that quadrilateral is a parallelogram? I've not talked to Kristen, Emmett, Anya, Melissa. I did talk to Melissa. Anatier or Brooke. Is that sufficient?
Yes.
Yes.
Okay, Anya, go ahead. What's the reason?
It has 2 pairs of opposite congruent sides.
You don't mean that.
Oh, I mean opposite congruent angles. Sorry.
So if a quad has 2 pairs of opposite congruent angles, then it's a parallelogram. Okay, then we're starting over. Okay, the next one says angle A is supplementary to both B and D. A is supplementary to both B and D. Okay, anybody who hasn't talked to me?
Yes,
Okay, Brooke, what's the reason?
because it has an angle that is supplementary to both of its consecutive angles.
Again, we're talking about quadrilaterals that have that property. So if a quad has an angle supplementary to both consecutive angles, then it's a parallelogram. Okay, A and B are supplementary. And C and D are supplementary. And then I know you've been trying, so if you want to answer this one, go for it. If not, somebody else can answer. Do you want to try that one, Emmett?
I'm not like totally for sure about this one.
Okay, do you want to try or you just want to go with somebody else?
Someone else can do it, but I know the last one.
Okay, I'll come back to you then. Kristen Panatier,
Yes.
what do you think? Is that enough to say?
It's not enough to say
Okay, Kristen, tell me why.
because, like, a kite could also have two supplementary angles.
I'm not actually sure if that's true. That's not true. A kite doesn't have any parallel sides. So if you have these two angles being supplementary here, that would make some lines parallel, which cannot happen in a kite. And again, I know that we haven't talked about kites, and so you guys don't know all the properties of kites. But when you're thinking about different shapes, parallelograms have two pairs of parallel sides, trapezoids have only one pair of parallels, and kites have no parallels. So there's other quads too that don't have any parallels, but kites have a lot of interesting properties, but they do not have any parallel sides. So you wouldn't be able to use kite as a counterexample, but there is something that we talked about today that you could use as a counterexample. Can you think of a different shape, Kristen, that would be a counterexample? Or can you tell me which one of these up here is it kind of similar to, but it's not quite the right thing?
The theorem 6-9.
Okay, it's kind of like this one, right? And actually, I didn't go through and say this at the time, but I don't care about the numbers of these theorems. I just need you to understand that the first one's a definition and all the other ones are theorems. But yeah, the third one,
Okay.
it's kind of like that one, right? But why is it not that one?
Because it's not proving that one angle is congruent, that one angle is supplementary to both of its angles.
Right. So if we had like this angle here, it's supplementary to A, but it should be supplementary to C also, if we were going to be able to say it's a parallelogram. So you would need both. Need an angle supplementary to both consecutive angles. I want a counterexample. Can anybody think of, you may or may not kind of be able to come up with this, but can you think of a shape that would have that property but that's not a parallelogram?
trapezoid? You said that they could be like, in a prior example, the trapezoid would have a pair of supplementary angles on like kind of the left side, like the one in the bottom left and the one in the top left.
Okay, so we could have something like 70 degrees here, and then the top one would be what?
110.
Okay. And then on the other side, what has to happen? So give me a number for that angle.
50.
Okay, let's say that one's 50. What would the top one have to be?
130.
So, and this is not isosceles. Trapezoids don't have to have like the same numbers over here as they have over here, right? As long as you have two pairs of supplementary angles, that's fine. But the problem with this one is it could be a trapezoid because these lines with this transversal, since those angles, these consecutive interiors are supplementary, that would make those lines parallel. What lines are parallel because C and D are supplementary? What lines are parallel because C and D are supplementary?
BC and AD.
Yeah, it's the same ones, right? Who was that?
And Nazi.
Thank you. I thought it was. Like, you're the last person I need. Okay, so those two supplementary angles are going to give you the same parallel sides, right? Because it's still these two lines and then the transversal over here. So the problem is that you get the same pair of sides because of where the supplementary angles are. So if there's only one pair of parallel sides in the quadrilateral, it'll be a trapezoid and not a parallelogram. Okay, so again, this is kind of what a generic trapezoid looks like. Okay, and then Emmett, you said you were going to answer the last one, even though you answered something else, I think. AB is parallel to CD, and then BC is congruent to AD. Yes or no?
Yeah, I said that. I said no.
Okay, can you tell me why?
Well, wouldn't you need for each side to either be congruent and parallel to its opposite side instead of like just one or the other? You need both pairs to be congruent and parallel.
The same pair of sides, parallel and congruent. Can anybody think of a counterexample that it could be if all you know is one pair is parallel and one pair is congruent?
Could be an isosceles trapezoid.
That's that. So in an isosceles trapezoid, you have one pair parallel and the other pair congruent. So if that's all that you know, like maybe there are other properties where it would be a parallelogram, but this is not sufficient. That by itself is not enough for us to say that it's a parallelogram. Okay. All right, we are going to stop there because we're out of time. I want you to screenshot this proof and add it to homework number 2. Just stick it at the end of homework 2 and give that a try. We'll talk about that when we go over homework next time.